All right, 3.1. This entire unit is about the word linear. Just look at the first 4 letters of the word. What does it spell? Linear. Line. L-I-N-E. Everything we are doing has to do with lines. Straight lines. There are 3 ways to write the equations of the line. We are only going to look at one of those ways. The one way is ax plus by equals c. This is called standard form. And it's really, really good at doing one thing. It's really good at finding x and y intercepts. X and y intercepts. And that's what we're going to do today. We're going to use standard form and graphs to find our x-intercept and our y-intercept. This is standard form. Ax plus by equals c. It always has an x. It always has a y. A, b, and c are just going to be any old number. Could be positive, could be negative. All together, it makes a straight line. Okay? Before we talk about x and y intercepts, we should probably remember what an x-axis is. Do you know what an x-axis is? And a y-axis, where are they? Where's the x-axis? It's the flat line that goes across the bottom. If you don't know that, you need to take your pencil and write x-axis. The line going from left to right is the x-axis, and it has all x values on it. The line that goes up and down is called the y-axis and contains all of the y values. When you put an x value and a y value together, it creates a point on the graph. Yes?
Why is the line for the x-axis so like down?
Low. It's just not centered. It'll just depend on the graph. So, when the blue line, our equation, crosses an x or a y axis, we call it an intercept. Intercept sounds a lot like what word? Intersect. When 2 things cross. So, our x-intercept is when our blue line crosses the x-axis. Here it is, right here. There are 2 ways we can write it. We can write it as a point. How would I name this point? Starting in the middle, how far left do I go? 6. Negative 6 to the left 6. And do I go up or down?
You don't go nowhere, you stay right there.
So it's 0. Negative 6, 0.
Is it because it's in the negatives?
It's because it's on the line, but this is negative because it's in the negatives. Yep.
So is the dot is on, I don't get it.
The point is on x equals
And
negative 6.
that's negative 6 right there.
Yep.
If you know what you're doing.
The other way we can write it is we can write x equals negative 6. Both of them work fine. The y-intercept is where our line crosses the y-axis, which is right here. That's the y-intercept. The y-intercept as a point is, do we go left or right to get there?
No.
Nowhere. 0, and then we go up 10. 0, 10 is the y-intercept. Or we can write y equals 10. Those are intercepts, and standard form is the best way to write an equation for a line. It helps us find these intercepts. Every line has 2, an x and a y. Where do you cross x? Where do you cross y? That's what we're finding today. So, it's easy when you're given a graph, isn't it? You just look at the picture. Are we always going to get a graph? No. Actually, most of the time, what are you given? You're given the equation instead of the graph. So let's look at the... Oh, not yet, actually. We're going to do practice. Look at your first graph. Take a look. Where is the x-intercept? What number does it go through? X.
3 or 4?
Here's the x-axis, and it crosses at the number 3. 1, 2, 3. The 2 ways we can write this is we can just write x equals 3, Or we can write it as a point. The point 3, 0.
That's what
A
I'm like.
point, ready? A point on our graph, let's do some point practice, is made of an x value and a y value. X goes which way? Left and right, side to side. Y goes
Up and down.
up and down. You gotta think of it like we always start at your house. You know where your house is? Right here in the middle. This is your home. It's called the origin, the center of the graph. 0, 0. Starting here, a point gives you directions on how to get anywhere you want on the coordinate plane. For example, if we want to get here, that's our destination. How would we get there? I go over 2, and then I go down how many?
Because it's in the negative.
Because it's in the negatives. We went to the right, that's positive, that's 2. And then we went down 3. So guess what number I write here? -3. Right 2, down 3. Let's do another one. Let's do right here. To get to this point, starting at your home, what would I have to do? But we do left and right first. X is first. How many do I have to go over?
3.
Is that +3 or -3?
Positive.
+3, and then I go up 4. Right 3, up 4. We're going to do one more. Let's say I'm right here. I start at my home. How do I get there?
Go over.
1.
2, 3, 4.
But which way did we go?
Right. 3 left.
So that's -4. How high up or down do I have to go to get there?
Where you going?
I'm going right here. Do I have to move?
No, you don't gotta move.
I'm already there, so what number goes here?
0.
Why don't we?
0. 0 means you don't go up or down. So this point, what did we have to do? We had to go over
Over. Stay right there.
over 3 and then stay there. That's why there's a 0.
Oh, okay.
Okay, now let's try the y-intercept. Here is where it crosses the y-axis. To get there, you start at home. Do I go left or right?
No.
No.
I'm only going
Oh.
up how many?
3.
3.
2.
2. We didn't see your thing.
So my point, I stay here. I didn't go left or right. 0,
2.
2. Or you can write y equals 2. Do you see now? Okay, you're going to take 4 minutes to do the next 2. X-intercept, y-intercept.
We can ask questions.
I don't know. Can you?
I don't know. We can ask questions.
Mm. Alright. Middle one. This right here is the x-intercept because what axis is it on? The x-axis. This line crosses right there on x. Two ways you can write it. First is we just go left 3, negative 3. Negative 3, 0, or x equals negative 3. Done. The y-intercept is on the y-axis, the up and down. Here it is, right there. That's where it crosses. To get there, you don't go left or right, so you put a 0. You just go up 4. The point is 0, 4. Or you can write y equals 4. Last one. This is the x-axis, and where does it cross?
Left to right.
At negative 5. To get there, you just go left 5. Negative 5, do you go up or down? No. X equals negative 5. Done.
You did not help me. And I thought it was negative 4.
Now, we do our y-intercept. There it is. That's where it crosses the y-axis. To get there, you just stay in the middle, 0, and then you go down 2, minus 2. Or y equals negative 2. That is how you find your intercepts using a graph. Now, before we go on to the next slide, I want you to look at all the red x-intercepts. What do they all have in common?
That they all zeros
They all have 0 for what?
for the last number.
Which is the x or the y?
The X. Well, both.
The y. Do you see how all of the intercepts for x, their y value is always what? 0, 0, 0. X-intercepts have a y value of every time.
So,
Y's, what do you notice about the y?
they got zeros in the front though.
The x value is always going to be 0. And that's super important because now we're not going to have graphs. I'm taking your graphs away. No more graphs. No more graphs. Next page. Instead of graphs, what did I give you? I gave you the equation for the graph. This represents a line. We just don't know what it looks like. But we can still find our intercepts. And this is why standard form is awesome, because you can find intercepts super easy. To find the x-intercept, to find x, we just got to talk about what we just said. X-intercepts always have a y value of
0.
So guess what? If I were to plug in 0 for y, what would happen to 8y? 8 times 0 is just? It would go away, wouldn't it? So what you do for an x-intercept, you're going to take your hand and just cover this up. What's left? On
Negative
both-
6x.
Negative 6x equals,
24.
okay, we're going to solve a baby equation. Since the y value is going to be 0, we can just get rid of it. And we can solve to figure out what x is supposed to be. To solve this, all I do is and divide by negative 6. So what's x going to be? Negative 4. This is my x-intercept. So I go to my graph. I go to my x-axis, that's this one, going left to right, and I go over to negative 4. 1, 2, 3, 4. Lot of point. There's my x-intercept. What? So if we were to get rid of this y and multiply 8 by 0, what would it give you? 8 times 0 is just 0. So the whole thing would just disappear. Since we're multiplying 8, if we were to plug in 0 for 8, because don't we know the y value has to be 0? Because we're trying to find the x-intercept. If we plugged in 0 for y, 8 times 0 is just 0. So we know this whole thing is just going to disappear. So it gets rid of not just the y, but also the 8. Okay, now to find our y-intercepts, think, what are we going to do? For x, we covered up the y. For the y-intercept, what are we going to cover up?
The 6, the negative 6.
It's negative 6x. It's gone, and all that's left is
8y.
8y equals 24. We're going to solve this to find our y-intercept. Divide by 8, and y equals 3. That's my y-intercept. When I go over to my graph, and where is y equals 3? Up how many? Up 3. And guess what I can do now? There's the graph of my line, and its 2 intercepts. Now, Kravitz and I are all about shortcuts, okay? This is how you do it old school. We just did it all by hand. On the OST, you get Desmos.
What is that?
What you have on your computer, you get to use that on the OST. And if you didn't know, you have about 3 to 4 minutes for every question. This takes a while. I'm going to show you how to do it with Desmos really quick. So make sure you have Desmos open in front of you. I'm going to pop it open.
Man, I don't even got off the good. This might just stop myself.
Watch, it's not hard. Okay, to do this in Desmos, step 1 is type it in. Type in the standard form. Negative 5x minus 7y equals 21. And what pops up? There's my line. Now all we need to do is find our intercepts, which watch very carefully. Are you watching? Here's my little mouse. You're going to take your little mouse and you're going to click on the line. Watch. Highlight the line. Highlight the line. Highlight the line. What pops up when I click on the line? What are those? That's the x-intercept and the... If you're not clicked on the line, do you see them? You gotta click on the line and look. Boom, boom, answers. This is the x-intercepts. This is the y-intercept. Now, I'm gonna show you one other thing. On the OST, you will not type your answers in as decimals. If it's multiple choice, negative 4.2 would not be one of the selections. It would be a fraction. So the second thing I'm going to teach you with Desmos right now is you go off to the side. If you type in negative 4.1, do you see this button that pops up right here? Do you know what this does? It turns my decimal into a fraction. It wasn't 4.2 though. Yeah. 4.2. It turns my decimal into a fraction. This is how you will write your answer. This is my x-intercept, and my y-intercept is just negative 3. So all I need to do is on my paper write that x equals negative 21 fifths and y equals negative 3. X equals negative 21 fifths, y equals negative 3. I go to my graph. Negative 21 fifths is hard to graph. It's negative 4.2, so we go over 4 and a little bit more, 4.2. Negative 3, I just start in the middle and go down 3. Take my pencil and to the best of my ability, draw a straight line. There's my x-intercept, there's my y-intercept, here's the graph of my line. All because we were given standard form, we can do all of that stuff. And that's why standard form is great for doing this, finding the x and the y-intercept. The other ways to write a line are good for different things. This is good for what we're doing right now. I only have one more skill to teach you today, using standard form. We're going to do it by hand and then with Desmos. To do by hand, by Desmos. This is on the same page or the next page? Same page. Next page. Right after this. It's quick. After this. It's quick. Okay, the last thing we're going to do with standard form is we're going to figure out, is a point on the line true or false? 2, negative 3. We're trying to figure out, is the point 2, negative 3, that little point, over 2, down 3, is it on this line? To find out, we're going to plug some stuff in. So, what does this 2 represent? What values? 2 is the x, negative 3 is the
Y.
So I'm going to go over here to my first equation, and instead of writing an x, I'm going to plug in 2. When you plug numbers in, you always hug them in parentheses. 2 plus, what goes in for y?
Negative 3.
Parentheses, negative 3, parentheses. And what does that have to equal? 1. Now the question is, does 2 plus negative 3 equal 1? What is 2 plus negative 3? Negative 1. And is negative 1 equal to 1? No. So, do you think the point 2, negative 3 is on this line? No. False.
So that's how we always gonna do it.
Yes. By hand. The point 2, negative 3 is not on this line because it gave us a false statement. Second one. Same thing. Instead of x, we're plugging in 2 parentheses times 2 minus, what do I plug in for y? Negative 3. We need to see if this equals 7. Now, can you just plug all that into your calculator? Sure. Or we can use order of operations. 2 times 2 is? Bring everything down. Think before you speak. What is 4 minus negative 3? 4 minus negative 3. 4 minus negative 3 is the same as 4 plus 3, which is 7. Is 7 equal to 7? Is that true?
Yeah.
So that means what? I mean, I know it means it's true, but that means, what can you tell me about the point 2, negative 3? Where is it? It's on that line. If you were to graph this line and plot the point 2, negative 3, guess what? It would land right on it. That's how you do it by hand. But again, we're about shortcuts. So I'm going to show you how to see if 2, negative 3 is on these lines. Open Desmos. Oh my gosh, I'm such a whiner. Boy. Okay, settings, delete all. We don't need that anymore. Okay, type in your first equation, 3x plus 5y. 3x plus 5y equals negative 9. There's the equation of my line. Now I need to plot the points. The point is 2, negative 3. So you need, see how I plotted the point? I just typed it in. There it is. There's my equation. Here's my point. Now look at your graph. Is the point on the line? See my point? Is it on the red line?
No, yes.
Yes. Look at it. It's right on the line. If this was a road and the purple dot was a car, is it on the road?
No.
Yes, it is. So, is this true or false?
True.
True. The point 2, negative 3 is on the line 3x plus 5y equals negative 9. That is true. Now we do the same thing, but now instead of this equation, we're typing in 4x plus y equals 8. Is the car on the road? False. This is not. This point is not on the graph. I'm going to show you something you got to be careful of. Are you ready? Sometimes you dinglings will be like zoomed out a ton, like this. Now, does it look like that line is on the dot's on the line? Doesn't it look like it's on the line right now?
Yeah.
But that's because why?
We
We zoomed out super far. You'll also, someone is going to be like, Mr. Tokar, my line's not working. Why can't they see their line? It's zoomed out and dragged to the side. If you ever can't see your ish, you see this little house? This says take me home. You click it and look, we back home. This point is not on the line, so this is false.
Well, if it was something else, would you put something else? Like, is it like an equation? It was just false.
It's just false. It's asking, is the point on the line? No, it's not.
You would ever have to do something else. That's what I'm asking.
You're going to have to do exactly this, what I just showed you. That's it. False. Okay. We're done recording.